Hello, this work is the result of a collaboration between Maheen Rashid and Yong Jae Lee from UC Davis, Sofia Broomé and Hedvig Kjellström from KTH, and Katrina Ask and Elin Hernlund and Pia Haubro Andersen from SLU. This work uses the equine orthopaedic pain dataset developed at SLU. It features surveillance video footage of 8 horses from 4 viewpoints before and after pain induction. Being prey animals, horses can hide signs of pain from human observers. So surveillance video footage gives us horses expressing pain naturally, as well as multiple viewpoints. On the other hand, with just 8 horses and just periodic pain assessments, the training data is limited and the pain labels are weak. With weak labels and limited data, a network trained directly on images is likely to overfit to the training data by focusing on extraneous visual information, such as the hay or lighting in the horse stall. Our challenge is to force the network to focus on the important features of pain without overfitting. We exploit the multi-view surveillance data to first learn a viewpoint covariant latent horse pose representation via a multi-view synthesis module. The learned pose representation is then used for pain classification. By trimming away superfluous visual information, we can avoid overfitting. None of the data we use is directly labeled by vet experts. Instead, we use the pain labels from the closest pain evaluation to determine the pain of each 2-minute video segment in our dataset. The resulting labels are weak and are best used in a multi-instance learning setting. Each video clip is classified individually. The clips with the highest pain scores are averaged to determine the video level pain and no pain label. Note that the MIL loss in literature would average the highest pain and no pain scores separately to determine the video level pain label. By averaging over clips with the highest pain labels, our loss allows pain videos to have clips with no pain. This proves to be an important modification. Our multi-view synthesis module follows the work by Roden et al. From ECCV 2018. An encoder-decoder architecture is trained to synthesize viewpoint J given an input from viewpoint I. The latent pose representation is rotated by the camera rotation between viewpoint I and J before being fed to the decoder. At the same time, the latent identity representation is taken from another time instance of the same subject from viewpoint I. This encourages the pose and identity to be disentangled. Last, a background image of viewpoint J is fed to the decoder, so the network does not try to encode the background information into the network. As the horses in EOP dataset do not move very much and can jitter the cameras, we adapt this method to our use case by training on high motion frames and building background images for specific time periods. We compare pain classification with the atomic unit for pain classification as both frames and 5-second video clips. We compare against training from scratch and the conv-LSTM-based method of Broomé et al. Our best model uses frame-level inputs and has 60% accuracy. For comparison, human experts have just 51% accuracy on classifying pain from videos. We present an ablation study on the level of disentanglement in the multi-view synthesis module and show that better post-disentanglement leads to higher pain classification accuracy. Our novel multi-instance learning loss significantly outperforms cross-entropy and regular MIL loss. Segments found to be painful in our model show horses displaying stretching, weight bearing, lying down, backward ears, and other pain-related behaviors. The multi-view synthesis module trained with high motion frames is able to disentangle identity much better than one trained with uniformly sampled frames. Thank you so much. Please meet us at our poster session to learn more.